Okay, this is our first stop, and the visit with you is Dr. Hans Kandel. Hans is our state extension agronomist, and he specializes in broadleaf crops. And so Hans has a couple subjects he wants to talk about. One is to give a quick review of some things to think about as you start thinking about what soybean varieties to grow in the future years. And then he's also going to talk about a number of production management projects that he's been working on and others on campus, and so basically give you an overview of a number of production tips. Hans is originally from the Netherlands, and he has a PhD from NDSU in crop science, and he's been working for us since July of 2007.
Well, today I want to talk a little bit about soybeans, and behind me I hope you can see the sign here. It is an irrigated Roundup Ready trial on soybeans. I am going to refer to one of the handouts that is in your packet, and if you look at it is a handout with on the top it says just Carrington REC, and then it has some soybean variety, the brands and the cultivars and maturity, etc. information. So it is kind of a table form that I'm discussing. So as you may know that throughout North Dakota we have many RECs, we have many county plots, and we do a lot of work in variety evaluation. So one of the things that is done is when we get seed for any of the trials, we try to get a little bit of seed and put it in a special trial to look at iron chlorosis. Now I know on a little bit of a lighter ground you may not have it, and sometimes iron chlorosis shows up under heavy soil conditions when it is cool, wet, high carbonates and with high salts. Now the last couple of years we have seen an increase in the salt moving towards the topsoil, and we see some fields that you say, how come they are now all of a sudden yellow, looking like they have iron chlorosis, and that is maybe due to some of the salt issues. So one of the things we do is taking the varieties that are in all the trials and putting them under the worst field we can find. So the idea is to put them under stress and then score them for iron chlorosis. And the way we score them, if the plant is green, we score it with a 1. If it is really dying, we score it 5. So the higher the number, the less we like it. Now, mind you that not all scores are following the same procedure. So some companies have a different scale when you look at their literature. So as we are putting those varieties together in one location, we can kind of rate them against one another. So it is a relative scale depending on the specific year. Now 2012 we had a lot of rain in some of the areas that we planted them, and there was a lot of stress, so we actually ended up with very high incidence of iron chlorosis, which is good for researchers, right? We want to see some differences. So if you look at the sheet here, these are the varieties that are appearing in any of the varieties that are done by Blaine and his team. And if you look at it, the one on the dryland or irrigated or other locations indicate that in that particular trial this variety appears. So hold on to this sheet. When you later want to learn more information about them, you can go to the specific trial data for each location and find out how it performed. So I did them in alphabetical order based on the company and then based on the cultivar. And then I have two numbers there. The number for 2013 is brand new, just got out by Dr. Ted Helms. So that is a new information. We always put our information also on our variety trial location. Google NDSU variety trials, you get to our main web page, and then you pick the crop that you like the variety trials on. There is also already data on winter wheat. If you want to plant winter wheat in the next couple of weeks, variety data is there, but also this iron chlorosis data is there. So there is, I only report here data that we know for the Carrington location. So if you look here at the second column, it says irrigated. That is behind me here. So the way I'm looking at it, we have here a score in the first column, and that IGC score, as you can see, the first number is 2.2, the second is 2.5. So what does it mean? Well, if you go to the bottom of the page, it has a number called LSD. That means the least significant difference that there needs to be between two numbers for me to say that they're truly different. And that number is fairly small. It is 0.23. So if there is a difference of 0.3 points between the number 1 and 2, I know that they're actually significantly different in this particular trial. And this is not just one site, it is multiple sites with multiple replication. So you can look at the relative difference. That is what it is. It is not an absolute, because each field is going to be a different condition. So we can't predict how it will be exactly behaving in your field, but we know relative to the other ones, there are varieties that are more tolerant. So if you are looking at an issue with einchlorosis, this would be one of the factors to look at and get a maturity rating for your field. Look at the einchlorosis score, and then we're also going to talk a bit about other issues we need to look at. So the second column about IDC is the 2012. So if you just look at the numbers, you see the numbers are lower. So last year we had lower einchlorosis in our trials, but still the relative differences, that is what is counted for. And again, two numbers different, significantly different if the difference is 0.3. So when I'm thinking about variety selection, I really think about a couple things. One of the things is it has to be mature before the frost comes. And you know, we shouldn't really talk about frost, but the reality is we are in September and we can get the frost, you know, in the middle to the third week of September. So your soybeans have to be mature. If you look at the beans behind me, they're beautiful green, they were well watered, so they could take advantage of the growing conditions. But if a frost hits this today, these are not mature. So you want to have beans that actually mature before you frost. And that is why we have to select the maturity group that is most suitable for our region. Now, I know when we just look at last year's data, for instance, you may pick a variety that has a very late maturity, because last year was also a very warm, dry year, and a lot of the varieties made it. So we really need to look at long term if you're going to be maturing your variety. So one of the things that companies do is give a maturity rating, and then in our booklet we also report the day that the plant is physiological mature. And what that means is that 95% of the beans have the mature bean color, and everything that can go into the bean is in the bean. We can't harvest it yet, it is still too wet. So we need to wait till it is dried down, but that is the date, physiological maturity, 95% of the plant, and that's what we report in a calendar date. You know, if we typically get the frost by the 21st of September, if it matures on the 1st of October consistently, we're taking a risk. Some years you make it, some years you don't. So maturity is very important. The other things that I would suggest we pay attention to is also looking at the Phytophtra issue. Different varieties have different genes. Now I have here very timely information in your package. There is the variety information available. The date says 2012, but don't mind, the date is still valid. I don't have the 2013 data, it's still in the field, and most companies still in the field. So as we are approaching big iron, and you see some of the companies are offering seed, that's good. Just check in the book if you can find that variety and get some more information about it. So really what we are talking about in variety selection, it needs to be adapted to your local conditions. And we have a few trial pieces in here, and Sam is going to talk a little bit later about cyst nematode. If that is an issue, there is some information here. But also we have a trial where we over-irrigate soybeans in order to put stress on them. This year we have a lot of stress early in the season. Now we could use a little water in most fields. But if you have, you know, on average a year with a lot of excess water, variety is going to respond differently if you have a wet year compared to a dry year, but also among the varieties, if you put them under stress, some do better than others. So it is important that you are kind of looking at varieties that are well adapted to conditions that you may be experiencing. So that's something that I would encourage you to look at our booklet from the past year. If I think about variety trials and etc., there's a lot of interaction between various factors, and one of the things I'm presently looking at is also what I call water management. We are looking at how can you manage the water table in crops. But another thing is, in the long term for crop management, it would be nice if we could know the different growth stages of the crop. And if you look here at the booklet, you can see we have different maturity classes and groups. And what we have been trying to do over the last 6 years is going back to our data and to figure out how many growing degree days did it take from planting to maturity, and trying to kind of make a model with growing degree days for soybeans. So that is a project that I'm working on with Adnan Akuz. He is our climatologist, and hopefully in the future we will have something for you. If you have been following some of the ag news on soybeans, there were a couple of interesting stories this year about yellow beans. And when they were uprooting the beans, they found out that they didn't have any nodules. That was not expected, because they also applied some inoculum. So there are cases when you are in a newer field and you put inoculant on and you get water stress, excess water, that sometimes the population of those bacteria also goes down and you don't get good nodulation. So if you don't get good nodulation, the plant just is not fixing its own nitrogen and the plants stay yellow. So especially if you are thinking about an area of newer production, you know, it would be good just to keep on checking if you actually do have nodules, if your plants are yellow. There are other reasons why crops are yellow. We will talk about a couple of those ones with Sam Markel later. But we are also kind of looking at, well, in many of the places where they are making the top yields, whoa, they baby those soybeans, right? So over time we get a lot of requests and say, which product, which miracle product is going to, you know, bump my yield, you know, tremendously. And you know, we're trying to figure out which products work and which one are not. In general, it is very hard to unravel exactly what is going on. But one of the questions that often comes up is, what about nitrogen application? Well, over the last couple of years that we have done some studies on nitrogen, we do increase the yields, but up to now not enough to pay for the additional nitrogen. And the reason is, if you get good nodulation, the plant can fix its own nitrogen, and the crop can grow on the fixed nitrogen from the plant. But as we are hoping to push the yield limits maybe past the 60 bushel, then maybe there is a time when we need to start thinking of applying some fertilizer. So that is what I'm looking at right now, is at what time and how much should we do any split applications or slow release nitrogen, and what are the effects of those. So those are a couple of things that are being studied at the present time. I'm going to stop here and see if there's any question. Okay, so the question about planting date. So we also know, if you are looking at the season, if you can get a soybean planted as early as you can, we have some days on the clock from planting till a very critical period in the life of the plant, and that is when it goes from vegetative to reproductive. And there is a triggering event that takes place in the soybeans to go from the vegetative to the reproductive, which is taking place around the longest day. When the nights are getting longer, it starts to trigger the plant to flower. So the earlier we can plant, the longer the period is going to be from planting to bloom. From bloom to the end of the season, that period is kind of similar, regardless of the planting date. So really our benefit can be in the beginning of the season. So the earlier we plant, the more days there are for the canopy to close, to make the vegetative material in order to fill the beans. But you can have a very nice looking plant. If you don't have the moisture, it's still not going to fill. We always talk about August making beans. Well, if we have a big crop, it uses a lot of water. So actually it can be negative if you have too many leaves, and it will go kind of downhill. And then if you want to talk about row spacing, all our studies that we have done over the years, if we go from 30-inch and we go down to 22, to 15, even to 7, we will pick up some yield, because we want to close the canopy as quickly as possible, intercept most of the sunlight. These beans behind me, they are fairly tall, and they can intercept all the sunlight that is currently falling. You can't see any of the soil below the canopy. Okay, so the question is, if you plant too early, can you get negative effects on kind of the seed development, and maybe is there a way to counterbalance that with fungicides or insecticides or combination products or what have you? It is true, if you put a seed in the ground and it is very cold, it is, the water temperature is that 32, 33 degrees, you can have a chilling factor and you can have a lower stand establishment. I do not know if any of those fungicides or anything work, because it is really a function of the penetration of the water into the seed that does the damage, and that takes place in the first 24 hours after seeding. So if that is a very cold water coming into the seed, it will reduce your stand. A couple of years ago, if you have ever attended the Best of the Best, we've done some demonstrations where we put some seed in the fridge and see about water uptake. The plant will take water up as long as it is liquid, but you will get a chilling effect in the sense that the stand is going to be lower. But I'm talking about when we plant early, I still think about soil temperatures that need to be in the 50 degrees or so.